Problem 9, I think I'll just answer for you because I don't want to write all this out. A is, what's the main thing a compiler does? And well, a compiler takes a language like Python or C or anything that's not machine code and translates it. Sorry, Python isn't actually compiled, so scrap that part, but it takes a language like C and compiles it into machine code to be operated by the computer, because the computer can understand machine code. It can't understand C without being kind of converted first. So I think that's what a compiler does. An example of a set of strings that is not regular. So remember, our regular expressions are things that have that we can make with repeats, concats, or either's. I think the sort of stereotypical, the classic example of something we can't do with this is like AN, BN, where we have some number of A's and the equivalent number, the exact same number of B's. The reason you cannot do this is you might think, well, let's write out repeat A, and then let's just, let's say concat repeat A and repeat B. Well, that doesn't actually work because in this part you may have one A and 5 B's, but this says they have to be of equal number. So there's no way of making these repeats return equal number, but also having n be any possible number. So I could do something like concat A, and B, but I can't do this for any number n. So there's no way to make a regular expression that represents this. Okay, I guess I did need the whiteboard a little bit. 9C says, what is memorization and when is it useful? So memorization, not memorization, is, but I don't know, sort of similar. It's we're running an algorithm what's a good example for when we might need this? I'm not sure, but I would have to think a little bit more. It's when we're running they probably have an example in the so you have some sort of algorithm that needs solutions of smaller parts of the algorithm. So to do factorial 9, you need factorial 8. But say I was doing, 9 factorial twice, I wouldn't want to calculate 8 factorial multiple times. So maybe I store the value of 8 factorial so I don't have to recalculate it. Or maybe I'm doing 9 factorial and then I'm doing 10 factorial. Here I can store the value of 8 factorial and 9 factorial. So here I can just say 10 times the value I stored for 9 factorial. It is that you're storing a previous evaluation, a previous value that you got, and then returning, that you can use that in further calculations. Let me see if they have a good example in the solutions. Looks like they don't have an example anyway of something that does this. They just say saves argument result pairs during a computation and looks up the results instead of recomputing them. You'll get a lot of this in algorithms if you take that. It's a way to sort of speed up your program. It says, give an example for 9D, give an example of a sequential non-combinational circuit. So sequential circuits, I guess I do have to draw for this problem. Sequential circuits have loops in them. Combinational ones don't. So something like, so many possible combinations. Yeah, let's do it like that. This is a sequential circuit. Here's X, here's Y. Okay, that was easy. And then is there a 9E? Oh, there's 9E and F. 9E, we prove that there is no program to solve the halting problem. State the halting program for a racket program. I think this was also on a midterm, probably in the midterm review, but the idea is that we can't make a function called halts ? That will tell you if any given racket program will halt on some argument that you pass it, because it could it could be in an infinite loop without you detecting that it's in an infinite loop. So you cannot always determine whether your program will halt. Is the following procedure tail recursive? Let me copy down this procedure really quick. Find proc list 10. And then it says, if null n, otherwise proc coder list plus n1. That's proc coder list plus n1. Okay, is this tail recursive? So remember, tail recursion means you don't like build up, you don't modify the recursive call before, yeah, I think that's a good way to think. You don't modify the recursive call. So if I had something here like +1 to what you get when you return proc whatever, then that would not be tail recursive. But here I just say recursive call, right? It's just proc. I don't do anything to proc. So this will be tail recursive. It's really as simple as that. You can also think of it as like, if you build up something like +1 on +1 on +1 on +1 on +1 on 0, like this is what you might, I don't know how parentheses, but this is what you'll get as a tree of calls for something that's non-tail recursive. This is not a good tree of recursive calls, but like this is the sort of thing that you'll build up. Here will be my base case. This won't exist for anything that's tail recursive because it just returns the recursive call. Okay, was that the last one? Great, that's all of 9. Then we will move on to 10.